All right. So, welcome to the last lecture of CCNA Enterprise. And basically, today we are going to cover automation and programmability. So we will understand what basically automation is, and how this the network automation especially impacts network management. How what are the benefits? Benefits it gives, and apart from that, we'll see some other methods, right, uh, to perform the automation, and which all areas that we have that automation, programmability. So let's start with understanding actually how network automation impacts network management. Okay, so when we say how automation impacts the network management, see, normally network word is developing rapidly, right? And with these developments, network requirements has increased, and new methodologies are, also developed to overcome this improvement, right? So one of the technologies that help network worldwide about is the network automation. Getting my point? So uh, basically, with the network automation, complex network duties, let's say, for example, configurations can be done automatically. So if you want to perform any configuration in the network to the hundreds of devices, that can be done automatically. Isn't it awesome, right? So as you know, network engineers like configurations, right? Uh, uh, Normally, we like configurations, isn't it? I mean, we as a network engineer, we really like the configuration. But for a large network, it is a pain, like routers, switches, configurations, and that too, the number of devices, it can be difficult. So to overcome this issue, network automation is used, right? Right. And this makes network engineers role easier. Why? Because now, instead of configuring the devices one by one, you are configuring the devices in one go. So it is quite a lot easier, isn't it? So there are various benefits of network automation to the network management. Okay. Uh, I can say by using the network automation, network engineers normally, or maybe network administrators, these roles are getting easier and less time consuming, isn't it? So what are the benefits? The benefits of the network automation is reduced operation cost, right? Reduced the operation cost. So as you know that a lot of network activities has been done manually by human, and obviously this can cause a lot of manual errors, so that this can cause many errors, and ultimately this reduces the performance. So first of all, network automation also removes the error of the network as well, isn't it? How this the cost is reduced, by the way. Why? Because we can do many network activities, right, automatically and fastly. So ultimately, this will reduce the job complexity, and so it will need few person hours, not like the whole team. Obviously, it is eating up the people job as well. So instead of like many network engineers, few network engineers can be overcome, or can basically work together to automate the network, to maybe to troubleshoot, to upgrade configuration, and that is why it is less costly. So when it comes to the less costly, it is all about the human resources. Higher up times, as I told you, I mean, we need basically the number of and amount of time only to do this job. Why lower errors? It is since this is being done automatically, right? So, and human configuration is not involved, right? The errors would also be reduced. Effective staff. So, pretty much, same thing what we discussed earlier. So normally, because of the network automation, right, repetitive roles will be done by, by automation programs. Repetitive work means, let's say you want to perform some checks in the network, right? So we don't have to involve now someone to do that task. That can be done automatically through the monitoring or through any of the tools. Isn't it awesome? So ultimately, right, so this network staff can also be effectively reduced, and effectively can be reduced as well as can be done effectively. The less staff can done the job effectively. We have better network control because we do not have any human error, right? We do not have any human error. So we have better network control, increase business agility. Uh, so since it is automation, so it gives more, benefits. It gives more ideas, for the future network as well, right? So you see the lower errors, low cost, better network control, effective staff, increased agility, high uptime. What basically this high uptime is?
No downtime. No downtime.
See, yeah, network uptime is the first important parameter for a network. Do you agree? So with manual activities, network uptime can be, decreased because of the unexpected errors of engineers. But with automation, network will work without human error, and this will increase ultimately the network uptime. You do not need much of maintenance windows. You do not need, you don't have to bring that complete network down or do testing in the production network. So that is basically the higher uptime. Make sense, guys?
Yes, sir.
Okay, so that's about how the automation impacts network management. Next is basically they compare traditional networks with the controller based. So let me just paste it here. Compare traditional networks with the controller based networking. Now, related to what we have discussed, okay, related to what we have discussed here, it is pretty much same. What does that mean? It is pretty much same. See, normally, as I told you, whether it is WAN or LAN or maybe data center, anything, right? Anything, this basically has to be manually done. Like if you talk about WAN, right? So if you want to make changes on multiple routers, okay, what is the legacy approach? The legacy approach is you would access that device, make the change, save the configuration, log into other router, other device, make the change, save the configuration, log into other device, make the change, save the configuration. Like this, you'll continue, right? But now, because we have introduced for wide area network, we have introduced what? SD-WAN. Okay. For local area network, we have introduced SDXs. And for data centers, we have introduced ACI. So what these three things do? So for example, WAN, right? So we have now SD-WAN. So all the devices, all the WAN routers can be managed by a controller. Are you guys getting my point? All the routers, WAN routers can be managed by the controller, right? So ultimately, the network engineers does not need to think about every command on every device. One, why? Because the controller configures the device with the consistent and streamlined settings, right? And the result is faster ultimately and more consistent changes with fewer issues. So let me access, by the way, one of the controller. I may need couple of minutes to turn it on. I was not planning actually to demonstrate, but let me access one of the controller. Okay, and at least let's say SD-WAN controllers, and then we'll see basically how does it look like, and right. So we were talking about the in the WAN, basically the legacy WAN versus the Cisco is the controller based. So what does that mean actually? We have already discussed, if in case if you want to make changes on the WAN routers, right? Specifically, I'm talking about WAN. So if you want to make a changes on WAN routers, then you have to log into one device, make the change, save the configuration like this. But this controller based control means you have now visibility, you have flexibility. For example, in SD-WAN, these are the architecture of the SD-WAN, where we have the orchestration, which is called vbond. Okay, we have for management, we have which is called vmanage controller, right? We have for control plane, we have vsmart, right? It is also important, basically, I'm just clubbing other topic as well with this, to basically the topic, which is let me share this as well. So the topic I'm talking about, this one, the control plane and data plane. Very important to understand this control plane and data plane as well. So anyways, once we understand this control plane, then I'll come back to this controller. Okay, so uh, let me just give one example here itself, what is basically control plane and what is data plane. So consider this is one router. Okay, this is one device. This is a one device, could be the router, could be the switch. Every device, basically, they have certain planes. What does it mean, plane? Certain plane means you have control plane, you have management plane, and you have data plane. We will specifically talk about the control plane. Okay, control plane. What basically this control plane is? Let me just put one more device to make you guys understand in better manner. So let's say these are the two devices, two routers, I would say, to be more specific. Okay, and in this also we have control plane. In this also we have control plane, right? And then you have data plane. You have a data plane. So basically here, what happens in the control plane? The control plane, whatever configuration that you perform, okay, that actually takes it in the control plane. What does that mean? Whatever configuration that you perform, for example, let's say these are two routers, right? And this router to exchange the routing table, let's say routing prefixes, you would use some short, you have some routing protocol, right? Let's say you are using OSPF. You are using OSPF. So OSPF, when you configure, and with the help of that OSPF, when these routers build the what RIB table, right? Uh, when they build the RIB table, well, I don't know why this big. Uh, yeah, we have to change to again. Okay. Yeah. So when these two routers form the OSPF neighborship, they will exchange the prefixes, right? And where does router keep that prefixes? It keeps in the RIB table, routing information base, RIB table here, routing information base, isn't it? So that all learning would go to the control plane. Okay. Similarly, if you configure access list, that would go to the control plane. uh, MAC address learning, everything, whatever they two devices that they learn, right? That information would go to the control plane. Okay. Then when does that data plane comes in a picture? The data plane comes in a picture when the real traffic comes. So let's say the traffic comes on this interface. Okay. uh, what this router would do, it will check the control plane for the routing. It will check the routing table, and from the routing table, it will download forwarding information base, right? It will download that table for the forwarding under the data plane and then forward it to the exit interface. So ultimately, shall I say this? Data plane comes in a picture when the real time traffic comes. If no traffic, no data plane, only the control plane. Data plane is built, obviously, there would be a cache after that, right? So as soon as the traffic, real-time traffic comes to the device, that time it'll seek that information. It'll, get that information from control plane. What is next hop IP, right? What is destination, next source, MAC, destination, like all that information, and keep that under the data plane. And through the data plane, the traffic would be forwarded, right? Getting my point? So this is basically the control plane and data plane. It is very important, and this remains same. This architecture actually remains same. So coming back to now this, similarly, this architecture like controller I was talking about is specifically here the vmanage. Okay. So this vmanage, the controller, it is a controller in the SD-WAN, software defined WAN, right? So this vmanage performs. So we have a central actually controller. Okay. And all when WAN, routers you see here.
Sir, your voice
They,
is very, very low now.
I don't know why. How about now?
Yeah, it's good. Thank you.
Okay, maybe Mike actually moved here and there. Right. So the vManage is a controller. So as you see, all the WAN routers, what will happen? They will get registered with the vManage. So ultimately, vManage have a complete visibility about, let's say if you have 100 devices, 100 edge routers, okay? So all 100 edge routers, software defined routers, managed routers would get registered with the vManage over here. So you can see all those devices. So ultimately, that means if I want to make changes in all 100 devices, what I can do, I can build a template, isn't it? And push that template from this controller to hundreds of devices. And that configuration would go in a second, within a fraction of second, that implementation is changed, that is changed, right? How nice this is, isn't it? So from one controller, we are managing the number of devices. Yes, these all devices should be able to reach the controller. They should be able to they should be registered with the controller. Obviously, if they're not registered, then we can't, right? So it is mandatory those devices should be registered with the controller. And then you as a network engineer, you would create the template, maybe device template, maybe routing template or anything, right? Create the template and push that configuration, whatever configuration you want to. For example, you want to configure, let's say this is the, these are the interfaces going to the LAN, and you want to configure in all the devices, you want to configure OSPF, okay, and advertise this network. So simply you would create the template and push that configuration from this vManage to all the devices. Here we go. The job is done, right? That is why you need also uh, so obviously in order to perform these tasks, you should know SD-WAN, right? How to operate, how to configure, how to create the device templates, what is vManage, what all task it performs, right? And that basically comes under the CCNP, enterprise in detail. Does it make sense, guys? So this is basically the compare traditional networks with the controller-based networking. Perfect. So the next we would talk about the northbound and southbound APIs. We will discuss what are these, okay, and how basically. So see, these are the some of the configuration and some of the flow wise actually, right? Flow wise. So as you see here, this is the controller, or this could be a server, or this could be anything, I would say. uh, but it sits basically at the central of your network, right? Could be controller, could be any device, right? So you need to understand what is basically the northbound APIs and the southbound APIs. So as you see in the network also, a northbound interface is an application programming interface, which is API or maybe protocol, okay, that allows a lower level network component to communicate with the higher level or more central component. What does that mean? Northbound interface. Yeah, northbound interface. What does it mean? This means you see this all third party, all are the endpoint devices, okay, and they all are communicating basically like RESTful, SNMP, FTP, right? They all are communicating with this device. So this is northbound interface again. So northbound interface is an API or maybe a protocol that allows a lower level network component to communicate with the higher level or maybe more central component, right? Central component, where I will explain more, right? While conversely, a southbound interface, right, allows a higher level component to send command to lower level network. So here we have a server with these are the higher level devices, could be router, could be switches, could be maybe firewall or anything. Whenever they communicate with this, that basically is called southbound interface. And when this lower end devices communicate with this, that becomes a northbound interface. In normal network scenario, let me just build a topology here. Maybe let's say this is router, maybe this is a gateway that we have been talking about, and then you have a switch, okay, and then you have endpoint, could be server, could be device itself, endpoint, okay. So whenever this endpoint communicates with this, so which bond it should be? Northbound interface, right? Northbound interface, because this lower level is communicating with the basically central device. Now this switch is connected to the gateway. So when this is also somewhere central and it is communicating with the higher, so this is also not. But when the traffic comes from the outside, let's say, and this gateway sends that data to the this device. So ultimately higher level to lower level or central device, the communication is happening, right? That is called southbound API. Does it make sense, guys? So let's say northbound API, some of the example. Okay, a device that is capable of sending out maybe syslog messages, but that is not configurable, okay, by the user. It is said to implement a northbound interface. Means other example like SOAP, IPMI, Smash, or anything, right? These are some of the examples. Whenever these devices communicate from with this FTP, SNMP, right? This is not board interface. Whenever these guys send this SNMP, the communication is not board. So what to be said? It is to be said that to implement a northbound interface. Okay, what is to be said? It is to be said that implement a northbound interface. You may get sometimes requirement like this from your network engineer or from your tech lead or escalation, saying check the northbound interface. From this point, check the northbound interface. So you should know basically what does that mean, right? And similarly, on the other hand, okay, we have southbound APIs. So southbound APIs, as I told you, from the higher end to the lower end, could be your Juniper, Arista, IBM, Cisco, these higher end devices, okay, would communicate basically with the central point or lower, that is called southbound interface. So you may get some requirement, and it is to be said that check the southbound interface, applications. Does it make sense, guys?
Yes, sir.
Perfect. Next, basically, is the compare traditional campus device management with the Cisco DNAC enabled device management. What is DNAC actually? Cisco DNAC. Have you heard of this DNA center? So we have talked a lot about these centralized controls. We have talked about SD-WAN. We have talked about SDXs. We haven't talked about much, but at least now you have idea to manage the controller in WAN. We have SD-WAN, the controller to manage LAN. We have SDXs, and then we call it SDXs. And for the data center, we have ACI, and the controller is APIC, right? So what is DNA center, or we call it DNAC, right? So Cisco DNAC, basically it is digital network architecture. What? DNA software, Cisco DNA. So it is basically a digital network architecture center. Okay. Normally, when you say this, compare traditional campus device management. What are the campus device management, by the way? Anyone? What are the campus devices?
Is it within the same company, I guess?
Yeah, anything like routers, like switch, IP phones, access point controller, wireless controller, any device, right? These are the campus net devices. And again, if you want to make those changes, legacy through legacy architecture, you have to log into one by one. We do not have central control. It is all different. It is all isolated here and there, isn't it? Now, DNAC, or it's again software defined architecture, controller, which is managed from the Cisco DNA center. Okay. So ultimately, we use Cisco DNA as a controller in a network, okay, that uses SDA, or you see that uses the SD access, that uses the SD access, isn't it? Or as a controller to manage traditional network. So ultimately, how would you do that? Normally, we can install Cisco DNA and then gradually migrate our network, add all those devices to the DNAC, right? So the DNA center appliances normally they come as a pre-installed with this DNAC center application. What all we can do? We can connect to the Cisco DNS controller. Via how you can control it basically. You can you can you can use GUI to access or to connect DNAC, or a script that access the controller's REST API. Okay, third-party app that access the controller REST API. Right? So ultimately, see, we can connect this Cisco DNA controller via this controller GUI, this script that accesses the controller REST API, a third-party app that access the controller via again REST API, a script that access third-party app via REST API, right? So these are some of the method to connect basically the DNAC. So ultimately, what would happen? Ultimately, all these network components, okay, that you see would be added to the DNAC controller. And from there, it is SD access only. I was telling you, right? For the LAN, we have SD access. It's again controller based application that basically, manages the LAN devices. Could be wireless access point, uh, could be, switches, could be routers, could be other servers, and etc.
So can it be Cisco Meraki devices as well, or just Cisco?
Meraki itself is a SD-WAN, right? Meraki itself is a controller. But
Right.
when we say, Cisco Meraki, Meraki doesn't actually control your normal Cisco switches or normal Cisco routers. Getting my point? That means it has to be a Meraki device. So Meraki access point, Meraki IP cameras, Meraki, switches, Meraki MX series security
Firewalls.
devices,
Yeah.
firewalls. It all should be the Meraki itself. Then the Meraki, we have a Meraki controller actually to control those devices. Similarly, yes, you got the point. Similarly, you have the SDXs.
Okay.
But because SDXs, it supports all all type of yes, you can integrate Meraki as well with the SDXs or the DNAC, right? Is it clear, guys?
Yes, sir.
All right. So next is describe characteristics of REST API, REST-based API like CRUD, HTTP, verbs, and data encoding. So let's first understand what is this REST-based API? What does that mean? See, this RESTful APIs, what are they? They are the interface that two computer systems use to exchange information securely over the internet. Okay. So most business actually applications have to communicate with the other internal and third party applications to perform various tasks. Do you agree? So we have there the REST API. It's again a programming interface again. Okay, so the REST API again would use GET request to retrieve, to retrieve a record, or maybe POST request to create one, or PUT request to update a record, or maybe delete. There are so many actually, components of it. Delete request to delete one, isn't it? So it's a programming interface. I can say it's an interface that two computers use basically to communicate or exchange the information, right? Now, what basically the CRUD is? What is the full form of REST basically? Representational state transfer, okay, or REST. So again, this is basically the architectural style for creating APIs, okay, that communicate over the HTTP protocol, isn't it? So we have on top of that, we have then CRUD also, right? So behind the scenes, what happens? APIs often need to manipulate data as part of their operation. Manipulate means maybe change, you want to change the behavior or something. Typically, these data operations called CRUD. Okay, so the CRUD is nothing but create, read, update, and delete. I told you, right? The REST APIs, the components we've discussed just now. I mentioned what? Some of the components: create, read, update, and delete. So you know basically what does that create means, what does that read means, update means, and delete means, right? Which basically make up these four fundamental operations. So now because REST API calls or CRUD operation, it is very important to understand their relationship with one another, right? For maybe API developers perspective. So what is CRUD here? So the CRUD is, it basically, the CRUD operations, you can say, apply to a traditional, relational database manager. What are the databases that you have? Databases that you have. You have, for example, you have SQL Server, right? That's the database. And then you have also MongoDB. These are all databases actually. You have Dynamo DB. So these are the databases, isn't it? So CRUD generally refers to record-oriented operations in computer database. So record means the database again. So the CRUD is used basically to maintain, to modify, to read, or to actually, delete the databases. Ultimately, I should say this operations, right? For example, create. A create operation adds a new database record. Like let's say the SQL equivalent for the operation, right, is normally insert. Read is basically to read it. Update if you want to update in SQL. Delete if you want to anything that you want to delete in SQL. Right? So that basically is a CRUD. Make sense, guys? HTTP we have seen already. What is the HTTP method that you have? So whenever basically the client, or you can say the HTTP methods, so this REST, if you are RESTful API request using HTTP methods, we have GET. What is GET? The GET request asks the API to retrieve a resource. What? Retrieve a resource. That is called get. Let's say such as database record or the contents of a file, right? Then you have post. So with the post method, the client sends data to the API server, which creates a resource with the supplied data. So what does it post? Client sends data to API server. Client sends data to API server. And again, why? To create resource. Then you have put method also. So again, client sends put request, okay, to API, and normally it points to the URI of any request. So ultimately, the client should have any of the URI, uniform resource indicator. So put request to the API. And last, not last, actually, last two, patch and delete method. Patch and delete method. So normally client sends patch request to the API partially, okay, to update the existing resources, and delete means delete, to delete the existing resources. So update the resource database. Resource, existing resources, delete the resources. Okay, so these are the some of the HTTP methods. So have you ever wondered, have you ever thought that whenever you are trying to access, through HTTP, any of the websites or anything, these are the message back and forth used, right? Next is recognize the capabilities of configuration management mechanism like Puppet, Chef, and Ansible. Okay, these are another actually. So the automate maybe tool you can say, which is used for. So Puppet is again tool. What is Puppet? So Puppet is a tool. Okay, it's a tool actually that helps you manage and automate the configuration of server. Okay, what does that mean? So ultimately, what I'm trying to say here, you got it. It is a tool, right, to basically manage and automate the configuration of any server. So ultimately, when you use Puppet, right, you define the desired state of the systems, right, that you want to manage. What those states are? Maybe it could be using domain specific language or DSL, Puppet code, or anything. So some of the server agent architecture, let me just put it here. Okay, so as you see here, we have agent and primary server, agent and primary server, right? So it basically uses the different states like facts, catalog, okay, report, and then finally report to the database. So the primary server and the agent are part of the Puppet platform itself, okay, which is just normally getting my point. So these are some of the platform I should say. These are the some of the steps that Puppet uses to get this job done, like consistency, automation, right? Similarly, Puppet, you have the Chef and Ansible also. You have Chef. So Chef is again configuration management tool. Puppet is also a tool which manages the infrastructure. This is basically code wise, writing code, right? Like rather using the manual approach, writing code rather than using a manual process. So and we all are using for what? To automate, right? Puppet, Chef, Ansible to automate, test it. That can be automated, that can be tested and deployed very easily. So normally Chef works on under the client and server architecture. Like here also the agent and primary server that Puppet works. The Chef works on the client server architecture. And ultimately it supports multiple platforms. Let's say Windows, it uses it supports Windows, it supports Ubuntu, CentOS or Solaris, all that it actually supports. And then Ansible is again also right. So you have again Ansible is also again it can be used to provision or configure any of the infrastructure like network devices. It is widely used actually. Chef is less used, but Puppet and Ansible on both on top actually Ansible is widely used. Okay, Ansible scripting and all. So and this is used in the network devices automation, and maybe it could be the bare metal server hypervisors. There we use Ansible, and we can ultimately install these Ansible services, and compute hosts. It's again open source. All are open source here. Okay, IT or automation tools. Basically, that automates provisions, configuration management, application deployment. Then Ansible, and then other languages also there actually. Jenkins. We will not talk about that. So Ansible, you can use Python again, right? So again, it's a tool written in Python, and it used to mark also you can say the YAML to describe the state. And
So
next
for
you, yeah,
exam, do we need to learn like Puppet, Chef, and Ansible as well, like, or do we just need a basic understanding for the
basic
CCNA exam?
understanding, just a basic understanding. Their usage and basic understanding. You don't have to learn anything because as you see in the what I have given the content, right? So it is all explanation, but no lab, nothing. So you need to have a basic
So
understanding.
if someone's studying for CCNP, do he
Mhm.
have to learn all this stuff?
Ultimately, no, but as I told, since now things have been, changing into or have been changed to the automation, so down the line, having automation knowledge is quite important. And for that, you can, target initially the Python language. And if you know the Python actually, then you would ultimately learn the other components as well, right? So it is not that really important. It is all your requirement. So if you don't know that, it is still okay. People are there, who are working without this. But having knowledge, see, initially as a fresher or 3 4 years experience, right? You won't be working on this network automation and all. But yes, there would be a time when you are consultant architecture and all that, right? There you have to make the things easy for the customers. And that time you knowing automation and all, it is good if you have shell scripting, if you know shell scripting, if you know Ansible, if you know very good, if you have very good idea about the Linux command and all, it is good.
Okay.
Okay, so the next basically is interpret, and the last topic of this lecture as well as the course, interpret JSON encoded data. So what is basically JSON? The full form, JavaScript Object Notation. Okay, so I can say this JSON is a lightweight format, for storing and transporting data between again client and server, or between two endpoints, or two server and client. Uh, this is often used when data is sent from server to a web page, or web page to server back. It's kind of easy to understand, self-describing actually. Some of the examples, it is again object basis, record basis, right? So JSON script is something, again, it, as I told you, it is Java based script, right? Java, the full form itself is JavaScript Object Notation. And Java is one of the language, isn't it? So code basis. So creating JavaScript objects, and this is where we use JSON. Do you guys have idea about the Java? I guess no, but maybe yes, a little bit. Yep. So I think we are done with this, automation and programmability part. If you have any question, just let me know.